So, let's start with the basics. In the world of security cameras, you have a few key players. First up is the NVR, which stands for Network Video Recorder. Think of it like a specialized computer whose only job is to collect video from all the IP cameras connected to a network. It's the central hub, the library where all the video footage is stored, usually on big hard drives. You can log into it to see live video or go back and watch something that happened yesterday or last week. It's a solid piece of kit, but on its own it's mostly just for recording and playback. It's reliable, but it isn't necessarily smart. Now this is where the analytics server comes in. This is the real brain of the setup. An analytics server is a powerful computer, often packed with high-end GPUs which are great for processing video. Its job isn't to store the video for long periods, but to watch it in real time and understand what's happening. It's like hiring a super smart security guard who can watch hundreds of cameras at once without ever getting tired or distracted. This server runs sophisticated software, powered by artificial intelligence and machine learning to look for specific events, objects, or behaviors in the video feeds it receives. The NVR and the analytics server work together as a team. The NVR handles the heavy lifting of recording and storing massive amounts of video data 24/7. It ensures that you have a complete record of everything. Meanwhile, the analytics server taps into that video, either live as it comes in or from the recordings, to add a layer of intelligence. This partnership is what elevates a standard surveillance system from a passive recording tool into an active, intelligent security solution. It's a classic case of hardware meeting smart software to create something much more powerful than the sum of its parts. You can think of the NVR as the eyes of the system and the analytics server as the brain. The eyes see everything and record it faithfully, but they don't necessarily interpret it. The brain, on the other hand, takes all that visual information and makes sense of it. It identifies patterns, flags unusual activity, and turns a simple video stream into actionable insights. This collaboration allows businesses and organizations to get so much more value out of their camera systems, moving beyond just evidence collection and into proactive monitoring and operational improvement, which is a pretty big deal. So, how does the video actually get from the NVR to the analytics server? It's a process that's actually pretty straightforward, thanks to something called RTSP. That stands for Real-Time Streaming Protocol. Essentially, RTSP is a set of rules that lets one device request a live video stream from another over a network. The NVR acts as the source, holding all the camera feeds, and the analytics server acts as the client, asking for a specific feed to analyze. It's like the server is saying, "Hey NVR, can you show me what camera 5 is seeing right now?" The process begins with setting things up. An administrator logs into the analytics server's software and tells it where to find the NVR on the network by providing its IP address. Then, they specify which camera channels they want the server to analyze. For each camera, they provide a unique RTSP link. This link is like a specific web address but for a video stream. It contains the NVR's IP address, the camera channel number, and the necessary login credentials. Once this is configured, the server knows exactly where to go to get the video it needs for its analysis. Once the connection is established, the NVR starts sending a copy of the live video feed directly to the analytics server. This is important. It's a copy. The NVR continues to do its main job of recording the original high-quality video feed to its hard drives without interruption. The stream sent to the analytics server is often a secondary, slightly lower resolution stream, known as a substream. This is a smart move because it uses less network bandwidth and is easier for the server to process quickly, without sacrificing the quality of the main recording. This continuous handshake is what makes real-time analysis possible. The analytics server isn't just getting a snapshot, it's receiving a constant, live flow of video data, frame by frame. This allows the AI algorithms to see events as they unfold. The server decodes this stream and breaks it down into individual frames. Each frame is then passed through the analytical engine for processing. It's a seamless and efficient pipeline of information, moving from the camera to the NVR, and then branching off to the server for that extra layer of intelligence, all happening in the blink of an eye. Now for the really cool part, how the server actually analyzes the video. Once the analytics server receives the video stream, its powerful software gets to work. The core of this software is a set of AI models that have been trained to recognize specific things. Think of it like teaching a computer to see. These models have been shown millions of images and videos to learn what a person looks like, what a hard hat looks like, or even what certain human behaviors, like fighting or falling, look like. The server processes the video frame by frame, running each frame through these trained models. Let's take a concrete example, like personal protective equipment detection. The AI model has been trained to identify the human form and then to look for specific items on that form. It can pinpoint a person's head and then check if an object with the shape and color of a hard hat is present. It can also identify a person's torso and check for a high-visibility vest. If the model detects a person in a designated hard hat required zone but doesn't see a hard hat on their head, it flags this as a violation. It's all about pattern and object recognition happening at incredible speed. This same principle applies to more complex behaviors. For facial recognition, the server analyzes the features of a face in the video and compares it to a database of authorized individuals. If an unrecognized face appears in a secure area, it triggers an alert. For detecting sleeping, the AI looks for a person who has remained motionless in a specific posture for a set period of time, something a human guard might miss on a busy night. For detecting fighting, the model is trained to recognize the rapid, erratic movements and specific body language associated with a physical altercation between two or more people. The beauty of this is that it's all happening in real time. The server isn't just looking at past events, it's watching the present. This allows for immediate intervention. An alert can be sent to a security manager's phone the moment someone enters a restricted area or the second a fight breaks out. This transforms video surveillance from a reactive tool used for investigations into a proactive system that can help prevent incidents or minimize their impact as they happen. It's a huge leap forward in what we can do with simple camera feeds. So, the server has detected a violation. What happens next? Just finding the event isn't enough. The system needs to communicate that information in a way that's useful. This is where reporting comes in. When the AI flags an event, say, a person not wearing a safety vest, it doesn't just forget about it. It immediately logs the event in a database. This log includes crucial details: the type of violation, the name of the camera that saw it, the exact date and time it occurred, and a snapshot or a short video clip of the incident itself as evidence. These individual alerts are just the beginning. The real power comes from aggregating this data over time. The analytics server can generate comprehensive reports that give you a bird's-eye view of your operations. Instead of just knowing that one person wasn't wearing a hard hat, you can see a report that shows there were 15 hard hat violations this week, with most of them happening at a specific construction site entrance between 7 a.m. and 8 a.m. This is no longer just a security alert, it's valuable business intelligence that points to a specific problem area. The reports themselves are designed to be simple and easy to understand. You don't need to be a data scientist to get it. They often use visual tools like charts and graphs to highlight trends. A pie chart might show the breakdown of different types of violations, while a bar graph could show which cameras or locations have the most incidents. This makes it incredibly easy for a manager to spot patterns and make informed decisions. For example, if they see a spike in sleeping on the job alerts from the night shift, they know exactly where to focus their attention. Ultimately, this technology is a game changer for safety and security. By automatically detecting and reporting on these critical events, it allows organizations to be more proactive. It helps enforce safety policies consistently, secures facilities by instantly flagging unauthorized access, and provides clear, unbiased evidence when incidents do occur. It frees up human personnel from the impossible task of watching every screen all the time and lets them focus on responding to real, verified events. It's a smarter, more efficient way to keep people and property safe.